All right, let's just jump right in. What if I told you that the fundamental constants of our universe, the numbers that literally define reality as we know it, aren't random at all? What if they all just fall out of a single, incredibly elegant geometric rule? Well, today we're going to take a look at a really ambitious new framework called Modal Theory, which claims to do exactly that.
So to get why this is such a mind-bendingly big deal, we have to look at our current best picture of physics, the Standard Model. And you can kind of think of it like this giant mixing board. It works perfectly, but it has more than 19 of these little knobs. These are the fundamental constants that we have to go and carefully tune by hand. We run experiments, we get a number, and we plug it into the equations. We know what happens, but we have absolutely no fundamental reason for why these numbers are what they are.
Take one of the most famous numbers in all of physics, the fine structure constant, alpha. It's the number that governs how strong electromagnetism is, and it's pretty close to 1 over 137. For decades, the smartest people on the planet have been asking this really simple, nagging question. Why that specific number, right? Why not 1 over 136 or 1 over 140? And the Standard Model's only answer to that? Because it is. That's just what we measure. Now, look, that's a correct answer, but it's also a deeply unsatisfying one. And it's exactly this kind of profound gap in our understanding that just leaves the door wide open for brand new ideas. So the big question is, how do we get past because it is? Well, modal theory says we have to completely rethink everything, and I mean everything, starting with our most basic ideas about gravity and reality itself. And here is the big conceptual leap. We're all used to Einstein's brilliant idea of gravity as curved spacetime. Matter tells space how to bend, and that curve in space tells matter how to move. Modal theory comes along and proposes something totally different. It says maybe physics isn't about things moving through space at all. Maybe it's about what the universe allows to exist in the first place. It's all about a fundamental set of rules for coherence. So in this picture, gravity isn't a bend in space-time, it's more like a strain in the very fabric of possibility. And that brings us to this core idea, coherence strain. Okay, imagine the universe is this perfectly synchronized orchestra. Well, the energy it takes to keep every single instrument playing perfectly in time across the entire vast concert hall, that's what we feel as gravity. So space-time curvature isn't the cause of gravity, it's just the sheet music, basically keeping track of all the effort. Okay, so if gravity is coherent strain, then what's creating this strain to begin with? Let's take a look under the hood at the engine that modal theory says drives the entire universe, right from first principles. It all starts right here, with this one single equation. All it does is describe two basic fields. You can think of them as these invisible energy landscapes, and the single way they're allowed to interact with each other. But the most radical claim, the thing that should make you sit up straight, is right at the bottom, 0 free parameters. Remember the Standard Model's 19+ knobs? This theory says, nope, the universe just self-assembles from this one line of code. You don't get to plug any numbers in.
Now, this engine doesn't just run on some simple flat space. The theory says the vacuum is actually folded back on itself into this really special shape called a Z3 orbifold. And this slide gives you the basic idea. It's kind of like taking a circle and folding it up into a shape that has 3 distinct, perfectly symmetrical sections. And this isn't just some math curiosity. The theory claims these 3 folds are the very reason we see exactly 3 generations of matter in our universe. The electron family, the muon family, and the tau family. It's built in from the start. And this is where it all snaps into place. As the early universe cools down, it doesn't just relax to 0 energy. The internal geometry of that pretzel shape forces the whole system to get stuck or lock in place at one very specific phase angle, 255 degrees. According to modal theory, this single number, which just emerges from the geometry, is the DNA for every other physical constant. Everything else, it just unfolds from here. So, let's recap. We've got a single equation, a pretzel-shaped geometry, and a 255-degree lock. That's the whole setup. But does it actually work? Can this system actually predict the numbers we see in our universe? This is the moment of truth, where the theory has to put up or shut up. So let's go back to that magic number, 1 over 137.
Modal theory doesn't measure it, it calculates it. It starts with what it calls a bare backbone value of 126, which comes just from counting the ways the geometry can vibrate. Then it adds this tiny correction for how the vacuum itself interacts with that structure, a process they call chiral dressing. And the result? It lands squarely on 137.036, which matches the measured value with absolutely incredible precision. It also gives us a totally new way to think about mass. Mass isn't something a particle has. Instead, it's a measure of its relationship with the vacuum. The seesaw analogy here is perfect. If a particle's properties overlap a whole lot with that locked 255-degree vacuum phase, it's really heavy, like the top quark. If there's barely any overlap, it's super light, like an electron. It's that simple. And what about the biggest mystery in cosmology? Dark matter? Well, modal theory's answer is just stunningly elegant. It says there's no mysterious dark matter particle out there for us to find. Instead, what we're seeing is fossil vacuum torque, basically a residual energy, a leftover tension in the fabric of space from that initial 255-degree lock. It's literally an echo of the universe's birth. So let's put it all together on a scorecard, side by side. Free parameters. The standard model has over 19 that you have to measure and plug in. Modal theory claims 0. The fine structure constant, measured by experiment versus derived from first principles. The Higgs mechanism, something we had to postulate versus something that's geometrically derived. Dark matter, some unknown particle versus a residual vacuum torque. The claim here is one of total geometric closure. It's a self-consistent system that needs no external inputs from us. Now, this all sounds absolutely incredible, right? But it could also just be a beautiful story made of math. For any idea to be called science, there has to be a way to prove it wrong. So the big question, is modal theory falsifiable? And the answer from the folks behind it is a huge, emphatic yes. In fact, the theory makes some really bold, testable predictions that, if they fail, the entire framework comes crashing down. This isn't philosophy, it's science. Okay, here's prediction number 1. You could call it the theory's kill switch. It predicts that a very specific experimental setup, this coherence shell cavity being driven at a high frequency, should produce a tiny but measurable thrust. And here's the kicker. If that experiment gets built and run, and the measured thrust is 0, the theory is false. Game over. Prediction number 2 takes us out into the cosmos. Because it redefines gravity, the theory predicts that gravitational waves aren't quite what general relativity says they are. There should be this tiny, tiny deviation, what they call a phase residual, embedded in the signal. Now, it's a subtle effect for sure, but it might just be detectable by our gravitational wave observatories like LIGO in the next few years. If they look for it and it's not there, the theory is in big trouble. So this is the grand idea in a nutshell. Maybe we don't need some ridiculously complicated machine with dozens of arbitrary knobs to build a universe. Maybe all you need is global consistency. From one simple, folded geometry, all the intricate constants of nature, everything from atoms to DNA to galaxies, can just unfold. Which leaves us with a really provocative thought. Could our universe, in all its breathtaking complexity, not be the result of a series of cosmic accidents, but the simple unfolding of a single, inevitable geometric truth? The theory presents itself as being mathematically complete and self-consistent. And all the math, all the code, it's out there. It's publicly available for anyone to audit. The experiments have been proposed. So really, the only question left is it correct?